Namaskara. Welcome to Irrigation and Bridge Drawing subject. Myself, Lokesh G, working as lecturer in Civil Department from Government Polytechnic, Kudligi. In this session, we are going to learn about canal drawings. In the previous session, we have learnt about different types of canals and their components. Also, we learned the drawing of canal with a cross section of partial cutting and partial filling for the given data. In this session, we are going to learn about components of canals and also to draw the canals in fully cutting and in fully embankment for the given data. After this session, we will able to draw the given type of canal cross section for the given data. So different types of cross sections in irrigation canals are, first one is canal cross section in fully cutting. When the canal structure is constructed below the ground level, it is known as canal in cutting. The entire structure is constructed below this ground level. Next, canal cross section in fully embankment. If the canal is constructed above the ground level completely, then it is known as canal cross section in fully embankment. In this, full supply of canal will be above the ground level. Next, canal cross section in partly cutting and partly filling. If the canal is constructed partially below the ground level as well as above the ground level, it is known as partially cutting and partially filling. The drawing of this type of canal we already discussed in the previous section, so you can visit that session and learn about that one. In today's session, we are going to solve a problem on fully embankment or fully filling canal. So before starting the drawing, we have to read all the data given in the problems so that we don't miss any data for drawing. So let's start the problem. Following are the details of a canal to be constructed in a fully embankment or filling. Bed width given as 4 meters. Slope of banking is 1.5 is to 1. That is, in banking it is 1.5 is to 1. Provide dowel on left side of the bank with width 1 meter and depth of 0.3 meter. So it is mentioned on the left side of the bank. We have to note down that one. Width of service road to be provided on the left side of bank 4 meters. Top width on the right bank is 3 meters. Freeboard is given as 0.8 meters. Full supply depth given as 2 meters. RL of ground level as 100 meters. RL of bed level as 100.5 meters. And RL of FSL as 102.5 meters. Top level of bank is 103.3 meters and saturation gradient given as 4 is to 1. With above details, draw the cross section of canal with a scale of 1 is to 100. So for this data, we have to draw the drawing. So I am going to follow these steps to draw this type of cross section of the canal. Let's see that one. So first we have to note down all the data one by one so that we can draw easily. So first step, note down all the RLs from the given data or problem and draw a line representing the ground level. So this is the first step. Before that one, I have chosen a scale of 1 is to 100, which is given as in the problem, and my all dimensions will be in meters. So first step, I have noted all the RLs. Now draw a line representing the ground level. So first I am representing the ground level. I just drawn this horizontal line and I have represented it as a ground level with RL of 100. Next, with respect to ground level, draw remaining RLs. With respect to ground level, we have to draw the remaining RLs. Let's see one by one. So after ground level, I am going to take this bed level. BL represents the bed level. It is given as 100.5. So the difference between ground level and bed level is 0.5 meters. So with respect to ground level, I am measuring 0.5 meters and drawing this horizontal line representing the bed level. Okay. Then the next RL they are given is FSL at 102.5. So the 102.5 comes above the bed level. So with respect to bed level, I am going to draw this line. So the difference between FSL level and bed level is 2 meters. So I am measuring 2 meters from this bed level. So I have measured this 2 meters from bed level and drawn this horizontal line representing the full supply level. Then they have given TBL as 103.3 meters. So the difference between the TBL and FSL. So with respect to FSL, I am going to draw TBL. So the difference between these 2 points is 0.8 meters. So I am measuring 0.8 meter from this FSL. So first I measured this one and drawn this horizontal line representing the TBL as 103.3. Like this, first we have to draw all the given RLs. Next step is to draw canal bed for given width at bed level. So the bed level is here. So we have to draw the canal bed width in this line. Let's see how to draw that one. So from data, I have taken bed width as 4 meters. It is given in the problem. So to represent that one, I selected this point and measured 4 meters from here to here and represented it as a bottom width of the canal. Okay, this is the bottom width of the canal with 4 meters as given in the data, and for ground level I taken this line. Next, draw the line of canal in filling for given slope and extend it up to the ground level. So next we have to draw the line for given slope and touch up to the TBL level. So side slope in filling they have given as 1.5:1. So from the edges of this bed level, I have drawn horizontal 1.5 meters and vertical 1 meter. And I have joined these 2 points and extended it up to the top level of the bank. This I have made this side also. I have drawn 1.5 meters horizontal and 1 meter vertical. Then I joined these 2 points and extended it up to the TBL level, top bund level. Let's see next step. Draw canal bank top width, dowel and service road. So top width of the right bank as given in data, it is 3 meters. First let's draw this one. So top width of right bank. So this is the right side end of the canal bank. So from this I have measured 3 meters and represented it as top width of the bank on right side. So in the left side, they have mentioned it as left side, the service road has to be done. So I have to write this dowel and inspection road on the left side. For that, first I have to write the dowel. See, From this edge, I have to write the dowel. In the data, they have given it as 1 meter. So, dowel as 1 meter. So, I have drawn 1 meter representing the dowel. Then I have to draw the slope up to the service road level, or they have given depth as 0.3 meters. So, this dowel depth 0.3 meters, first I have measured and marked it down. And to draw this sloping line, this comes in filling. So for filling, the side slope as they have given as 1.5 horizontal is to 1. So from this point, I measured 1 meter here and 1.5 meter here, representing the sloping lines, and I joined these two lines. And then I drawn up to this thick line, I drawn up to the service road level, or mentioning the depth of dowel as 0.3 meters. Then I have to draw the service road which is having a width of 4 meter as given in the data. So like this, I have drawn top width of the bank 3 meters and represented it as, and dowel with 1 meter and depth of 0.3 meters as given in data. Then I have drawn service road of width 4 meters. Then draw the line of canal in filling for given slope and extend it up to the ground level. Then we have to write this sloping line in this side and in this side, representing the filling portion, and we have to extend it up to the ground level. So side slope in filling they have given is 1.5 is to 1. So to draw that one, from this edge I have measured 1.5 meters horizontal and 1 meter vertical. Then I joined these 2 points and extended it up to the ground level, representing the filling portion. And same thing I have done on the right side, drawn 1.5 meter horizontal and 1 meter vertical, and join these 2 points and extended it up to the ground level. So this portion represents the filling portion which is above the ground level. Next step is to draw the saturation gradient line from full supply level. So full supply level lies here. So from these points I have to draw a saturation gradient line. Let's see. So from data they have given saturation line as 4 is to 1. So to draw the saturation line, first I have represented the FSL level with blue line. Okay. Then this FSL level and bed level, the difference between these two represents the depth of flow, and the difference between top level of bank and the FSL level represents the freeboard, and it is measured as 0.8 meters. It's also given in data. So from these edges, I have to draw the saturation gradient line like this. So to identify the saturation gradient lines, I have used dashed lines. So I have to use this slope. So I have drawn 4 meters. From this edge, I have drawn horizontal 4 meters and vertical 1 meter. So then I joined these 2 points and extended it up to the ground level. So this line represents the saturation line of 4 is to 1. Same thing I have done on the right side, horizontal 4 meters and vertical 1 meters. Then we have to join this point, these points, and extend it up to the ground level. So the line below this represents the saturated portion or wet portion of the bank, and this line above this portion is known as wet portion, dry portion or unsaturated portion. So like this we have to draw the saturation gradient line. Next step is to erase all unwanted lines. So in this drawing, we have to erase unimportant lines like this. These lines I am going to erase it. This line and these lines I am going to erase it. So after erasing it, we will be getting this type of drawing. So this represents the canal in filling. After doing that, we have to hatch the drawing wherever we require. I am going to hatch this portion to represent it as a filling portion. See, like this, I have hatched this portion. This represents the filling portion of the canal. Next step is to dimension the drawing. Wherever we require, we have to dimension the drawings. As far as possible, I try to mention all the dimensions. So I have represented this canal width as canal bottom width as 4 meters, the depth of flow as 2 meters, freeboard as 0.8 meters. This 3 meter represents the right bank top width, and this is 1.5 to 1 is the side slope in filling, and this is the dowel width, and this is the top width of the service road, and again the sloping line 1 is to 1.5. So after doing this, we can cross check with the data they have given, so whether we have drawn as per the data or not in this step. Next, label the drawing. So labeling, wherever I required, I have drawn the label. You can add labeling, extra labeling also for this drawing. I have mentioned dowel, service road, and saturation gradient of 4 is to 1, depth of flow I have mentioned here, and bottom width of the canal I have mentioned here, and top width of the bank, freeboard, and side slope of in filling. Like this, we have to finish the drawing. So following these 11 steps, we have finished drawing of canal in fully embankment or in fully filling. So the final output is come out like this. Finally, we have to represent like this. If any labeling or dimensions are missing, we can add it here, extra data. Okay. Now let's see the next problem. Following are the details of a canal to be constructed in fully cutting. So the previous problem we learnt is constructed in fully filling or embankment. In this problem, we are going to learn to draw the canal in fully cutting. The data they given are bed width as 3.5 meters, slope of cutting as 1 is to 1, width of service road provided on the left side of the bank as 3 meters, freeboard as 0.5 meters, full supply depth of 1.5 meters, RL of ground level as 100 meters, RL of bed level as 98 meters, RL of FSL as 99.5 meters. With the above details, draw the cross section of the canal with a scale of 1 is to 100. This is the data they have given. For this data, we have to draw the drawing. So to draw, I am going to follow these 9 steps. Let's see step by step. So in the first step, we are going to note down all the RLs given in the data. So I have noted down all the datas. Then I have taken a scale 1:100 as represented in the data, as asked in the problem. Then all dimensions will be in meter. So first step is to draw a line representing the ground level. I have drawn this line, horizontal line, and represented it as a ground level as 300 meters. With respect to ground level, draw remaining RLs. With respect to this line, I am going to draw the RLs of remaining RLs. So with respect to ground level, I am going to draw FSL level. So FSL level is 299.5 meters and ground level is 300. The difference is 0.5 meter. So I have measured 0.5 meters and drawn this horizontal line to represent the full supply level to 299.5 meters. Then the next RL they have given as bed level, which is 297 meters. We can write with respect to ground level or FSL level. I have chosen FSL level. With respect to FSL level, it is 2.5 meters. The difference between FSL and bed level is 2.5 meters. So from FSL, I have measured 2.5 meters like this and drawn this horizontal line to represent the bed level as 297 meters. Same like this, we can also take reference of ground level. So if you take ground level reference, the difference between bed level and ground level will be 3 meters. So I have to measure 3 meters from ground level like this, and you have to draw this line. You can choose any one. So the next step, draw canal bed for given width at bed level. So bed level is here. Here we have to draw the canal bed width. So in the data, they have given bed width as 3 meters. So I have measured 3.5 meters here and drawn this one to represent the bottom width of the canal. Next step is draw the line of canal in cutting for given slope and extend it up to the ground level. So now we have to draw a line representing the portion of cutting for the given slope from here to here, and we have to extend it up to the ground level. Let's see. So now in problem they have given side slope in cutting as 1:1. So from edge of the bed width, I have measured 1 meter horizontal and 1 meter vertical as given in data. Then I have joined these 2 points and extended it up to the ground. And same thing I have done on the left side also, from this point to this point, and I have mentioned 1 meter and 1 meter to this represents a berm distance between the cutting portion, top cutting portion to the road services or ground level. Next, draw service road and side drainage at ground level. So inspection road or service road, they have mentioned it as 3 meters. So leaving a distance or the berm distance of 1 meter, I have drawn this 3 meters. Measuring 3 meters, I have drawn this service road. Okay. After this service road, I have drawn side drainages, so that if a rainwater falls, it goes directly into the side drainages. For that, we have to provide the side drainages. So in the problem, they haven't mentioned any dimensions for that one. So I have taken a slope of 1:1 in cutting for these side drainages, and I have taken depth of 0.5 meters and bottom width of 5 meters. So for that, first you have to write this sloping line. For to draw the sloping line, you have to draw one vertical and one horizontal. Then you have to join these 2 points and extend it up to the required depth. Then I have drawn 0.5 meters here. Then to draw this sloping line, again I measured one horizontal and one vertical. Then I joined these 2 points and erased the unwanted lines representing this side drainages. Next step is to draw full supply level. So full supply level is represented here. Okay, let's represent that one. So at full supply level, I have mentioned the full supply level. Here, the difference between the full supply level and depth of flow is 2.5 meters. Sorry, bottom bed level and FSL level is 2.5 meters. So it is represented as depth of flow. And the difference between FSL level and ground level is 0.5 meters. It is represented as free board. Next step is to erase the unwanted lines. So in this drawing, these are the unwanted lines. So I am going to erase that one. After erasing those things, I will be getting a drawing like this representing the canal in fully cutting. So after this, we have to dimension the drawing wherever we required. So first I dimensioned the bottom width of the canal as 3.5 meters and depth of flow as 2.5 meters, freeboard as 0.5 meters, and depth of drainage as 0.5 meters, the the berm width as 1 meter, and this service road having a width of 3 meters. Then this berm width of 1 meter, and these side drainages having a dimension depth of 0.5 meters and with width of 0.5 meters with sloping line as 1:1. So like this, you have to dimension the drawing, and in this step also you can cross check whether you have drawn all the details as per the given data. Next step is to label the drawing. So I have done labeling. So I have represented this as service road, this as side drainages, and this as depth of flow, and this as bottom width of the canal, and this as freeboard, and this as side sloping in cutting as 1:1. Like this, we have to finish the canal drawing. So this drawing represents canal cross section of canal in cutting. So following these steps, we have finished the drawing. So the final output should be like this. So in this, you can see all the labeling as done and dimensions and done, and all the RLs are represented. And here we have to mention scale and all dimensions in meter. Now let's see some of the multiple choice questions related to this session. The reason or reasons in canal the berm is provided is to protect the bank from erosion, to provide a space for widening the canal section, to protect the bank from sliding down towards the canal, all of the above. So generally the berm is provided between the top edge of the cutting and the bottom edge or toe edge of the filling. So it is generally provided for all these purposes. So the answer has to be all the above. So answer is D. Next, the gap or the margin of height between full supply level and top of the bank. So options are dowel, berm, freeboard, and side slope. So generally the gap is provided between the top of bank and FSL is known as freeboard, and this freeboard is provided to avoid overflowing of water from the canal. So answer has to be C. So answer is C. Next question. A dowel is provided by the side of the inspection road for top of dowel is kept above FSL by a margin of freeboard. They are provided as a measure of safety for automobile driven on the service road. They act as a barrier between road and canal, all of the above. So all these are correct with respect to the dowel. So it is provided in between the canal flowing portion and the service road, and it acts as a barrier, and it avoids any vehicle to go into the canals. So the answer is D. Next, inspection or service road is generally provided for. Inspection roadway is provided for maintenance, provided to inspect all the parts of the canal, to maintain the efficiency of the canal, all of the above. So the inspection road is provided for all these things. Generally, first for maintenance and to provide and inspect all the parts, and by these two steps, the efficiency of the canal increases. So answer has to be all the above. So answer is D. Next question. The typical cross section of the canal shown in below picture is. So this is the picture. So the option is cutting, filling, partial cutting, and partial filling, none of the above. So as we can see, the ground level is here, and the canal bed level is below the ground level, and full supply level is above the ground level. So this has to be partially cutting and partially filling. So option C is the correct answer. So C is the correct answer. Let's see the next question. The typical cross section of canal shown in below picture is. So the options are cutting, filling, partially cutting, and partially filling, none of the above. So as we can see in the picture, the ground level lies here. So the entire structure of the canal is above ground level. So this has to be in filling. So the canal cross section is in filling. So the option B is the correct answer. Next, the type of cross section of canal shown in below picture. So this is the picture, and the options remain same: cutting, filling, partial cutting, and partial filling. As we can see, the ground level lies here, and the entire structure of the canal is below this ground level. So entire structure is constructed by cutting out the soil. So the answer has to be cutting. So answer is A. So these are my references. This is our team for irrigation and bridge drawing subject. Thank you. If you have any suggestions or remarks about the content, tools, or formats, please write us to this Gmail address lms.dtek@gmail.com. Thank you once again.